Hi friends, ready to learn the kinematic equations of accelerated motion? In this video, we are going to look at the concepts of instantaneous velocity, instantaneous acceleration, and equations where acceleration is not constant. We are going to use the powerful method of calculus to look at these equations. And we'll also use the calculus method to derive the equations of motion. I'm going to make these concepts really easy for you and explain you with some simple examples. So make sure you watch the video till the end. And do check out the full courses on our website and Android app Manocha Academy. I'll put the links below. And the best part is you can try out these courses for free. So do check it out. Links are given below. All right, let's dive into kinematic equations. I'm sure you've seen these equations before. What are these equations? These are the equations of motion. And remember the symbols here? U is initial velocity, V is final velocity, T is time, S is displacement, and A is acceleration. So these are equations of motion for an accelerated motion. But there's an important condition here. The acceleration needs to be constant. So the A that you see in these equations represents acceleration, and that must be constant. Which means that the velocity should be increasing or decreasing at a constant rate. But what if we have a motion where the acceleration is not constant? What do you do then? That's exactly what we are going to look in this video, because we will look at the kinematic equations for accelerated motion. And we'll use the mathematical concepts of calculus and look at these equations. And I'm going to make these concepts really clear for you. So let's dive right into it. Let's start with the concept of velocity. What is velocity? Remember, velocity is defined as the rate of change of displacement. And the formula is displacement divided by time. So if a body has a certain displacement or a change of displacement, you can denote that as delta S over a certain time interval, which we can denote as delta T. So the change in displacement by change in time is the formula of velocity. So let's take an example. Let's say a body travels a distance of 10 meters. So the displacement is 10 meters here. And let's say the time interval is 5 seconds. So we have measured its displacement over 5 seconds. So what will be the velocity of the body? Very simple. Change of displacement by time. So 10 meters by 5 seconds, it's going to be 2 meters per second. Now we have measured this over a 5-second time interval. Now within that time interval, maybe the body was changing its velocity, right? Maybe it was going a little faster, a little slower. Just like when a car travels on the road, it doesn't perfectly travel at a constant speed, right? Or at a constant velocity. So maybe it covered this 10 meters in 5 seconds, but the velocity was changing. So what have we really measured? That's right. We have measured the average velocity, the average over this 5-second time interval. So remember this important concept that this formula is really the average velocity over your time interval, and the average turned out to be 2 meters per second. But now let's say we want to find the speed at a particular instant. Like in the cars you have seen, there's a speedometer, right? So it shows the speed of the vehicle at that instant, not over an average time. Because whenever you're looking at this speedometer, let's say the car is moving at a very high speed, right? Or your bike is moving at a high speed. You will see it shows 60 kilometers per hour, 80 kilometers per hour. When you are stopped, it will show 0. When you're going slow, 10 kilometers per hour. So you have seen the speedometer constantly changes, and it is giving you the magnitude of this velocity, the speed at that instant. So that is what we call instantaneous velocity. And how will we get that? To get the instantaneous velocity, we must make this time interval very small. We cannot measure it over a long time interval, otherwise that will become an average. You need to measure it over a very short interval, like 0.1 second or 0.01 second or 0.001 second. Make that time interval very small So in physics or mathematics, we write it as limit delta t tending to 0. So when this time interval tends to 0, that is denoted as ds by dt. So here we are using the mathematical tools of calculus here, where the short time interval we denote it as dt. So ds by dt is basically your instantaneous velocity, where s is displacement and t is time. So you are doing a differentiation with respect to time of the displacement. So remember this thing, that your instantaneous velocity is going to be ds by dt. So let's write down that important formula, v equal to ds by dt. And you have done graph stuff also, right? So we can say that if you draw a graph of displacement versus time, velocity is basically the slope of that graph, because when you do ds by dt or delta s by delta t, you're finding out the slope. Remember, slope was y by x or change in y by change in x. So basically, velocity is the slope of the displacement time graph, and you can calculate it as tan theta at a particular point. But we'll talk about slope concepts in a separate video. In this video, let's focus on these equations and calculus stuff. To understand the concept and formula, let's look at an example. So here we've been given that displacement of a moving body is given by this equation s equal to 5t square plus 4t. So we can know the relation between displacement and time. And what do we need to find here? We need to find the instantaneous velocity at time t equal to 2 seconds and also the average velocity. So let's first start off with the instantaneous velocity. So guys, what is the instantaneous velocity formula? Remember, v equal to ds by dt. So we are going to use this formula, v equal to ds by dt. For instantaneous velocity, always use ds by dt. Delta s by delta t is for average velocity, right? So here I can get the instantaneous by substituting s over here. So we will do d dt, that is a differentiation of the displacement, which is 5t square plus 4t. And you guys know how to do this. This is all calculus stuff, so please revise your calculus because it is very, very important and very useful for this chapter. So we have to do a differentiation of this displacement, and we know that we can do differentiation of each of the terms separately. So this is basically going to become d dt of 5t square, right, plus d dt, I'll break it down, of 4t. Now you guys know how to do the differentiation. You bring the constant outside. So this is finally going to become 5 d dt of t square plus 4 times d dt of t. Now what is d dt of t square? In calculus, you know this formula, that d dx of x to the power n is n times x to the power n minus 1. So here my variable is not x, it's t. So let's apply that. So d dt of t square will become n times t to the power n minus 1. Here n is 2. So 2 times t to the power 2 minus 1, which is 1. So 2 times t. So use that formula and you will basically get 5 times 2t here plus 4 times, what is d dt of t? That's simple, it's 1. Again, you can apply that formula. It will be 1 times t to the power 1 minus 1, which is t to the power 0. So again 1. So this is going to be plus 4. So here we have got our instantaneous velocity v is 5 times 2, so that is 10t plus 4. So that is my expression for instantaneous velocity. So that is the general expression in terms of t. But the question said find the velocity at time t equal to 2 seconds. So it's very easy. All you have to do is substitute t equal to 2 seconds here. Done. So what is the velocity at 2 seconds? We can say at t equal to 2 seconds, the velocity is going to be v equal to 10 multiplied by 2 plus 4. So what is the answer? 20 plus 4, 24. And guys, don't forget the units, 24 meter per second. Actually, here we should have been given the units in meters, So that is missing in the question here, that the displacement should have been given in meters since time is given in seconds. But if the units are not given, then you'll have to write 24 units. Okay, whatever the unit is, kilometer per hour, meter per second. So there you can see that is our final answer here. So that's all you have to do. If they ask you instantaneous velocity, do the differentiation, do ds by dt, and if they ask you at a particular time, just substitute it and you're done. Next, let's look at the second part, which is average velocity between 2 seconds and 3 seconds. Now let's calculate the average velocity. It's been asked to find the average velocity between time 2 seconds and 3 seconds. So for that, we are going to use the average velocity formula. So my average velocity formula is delta S by delta T. Change in displacement by change in time. So we can write that as S2 minus S1, the change in displacement divided by change in time, T2 minus T1. Now what is the time here? T1 is 2 seconds and T2 is 3 seconds, right? That is the time which has been given here. And what is the displacement at these times? The displacement we can get using this formula, S equal to 5t square plus 4t. You just have to substitute the time over there. Very simple. So let's work it out. So S2, which means the displacement at 3 seconds, is going to be 5 times 3 square plus 4 times 3 minus the displacement at 2 seconds. So just substitute t equal to 2 there. So 5 times 2 square plus 4 times 2. So that's all. We've just substituted the time values in the displacement expression divided by the T2 minus T1, 3 minus 2. So simple. There you go. So now you just have to do your calculations here. So let's go ahead and do that. What will this be? 5 times 3 square, that means 5 times 9. This is going to be 45 plus 4 times 3 is 12 minus this we need to be careful about. This entire thing should be in minus, right? Should be under the brackets over here because we are doing S2 minus S1. So 5 times 2 square is 5 times 4. So that's going to be minus 20. And we have minus 4 times 2 is 8 over there. Divided by 3 minus 2 is 1. So just calculate what will you get over here. We are getting 45 plus 12. So which is basically 57 minus 28 divided by 1. So the answer is 29 meters per second. This is our average velocity. Average velocity 29 meters per second, and that is from the time 2 to 3 seconds. So see, it's very simple. Just use the formula and you can get the average velocity and just carefully substitute the values, calculate, and there you get your answer. So we have seen how to find velocity from displacement. Now how do you find displacement from velocity? So we know velocity is displacement by time. So you can rearrange the equation and you'll get displacement equals velocity multiplied by time. So simple. But this equation is representing your average velocity. So if you know your average velocity, you multiply it by the time, you will get the total displacement in that time interval. Right? So total displacement is average velocity multiplied by time. But what if the velocity of the body is changing over the time and you don't know the average velocity? So let's say we want to work with the instantaneous velocity. Then what do we do? So remember, for instantaneous velocity, how do we calculate it from the displacement? The formula was the instantaneous velocity. So I'll write inst, that is for instantaneous velocity, equals ds by dt. So to calculate it, what do? We do a differentiation with time. We do ds by dt. So you can see here we are doing a difference. Here we are doing a differentiation. This ds by dt is the differentiation in calculus. And that way you can find out the instantaneous velocity, the velocity at a particular instant. Now suppose we know the velocity at certain instances, right? We know the instantaneous velocity and I want to find the displacement from that. So how do I do that? So let's see if we can use this formula. So if you look at this formula, I'm interested in calculating displacement. So I can rearrange this and write it as, if I bring the dt here, so we can do v times dt equal to ds. Since we are interested in displacement, let's bring that to the left hand side. So, or I can write ds equal to v dt. What is the meaning of this equation? That in a very small time interval, if you multiply the instantaneous velocity, you will get that small instantaneous displacement in that small time interval. But we want to find the displacement over a certain time. So what do we have to do? We have to add up all of these. So the v dt values need to be added up across that time interval. And how do you do that? So here again we use the calculus method of integration, because finding that area, right, adding up all these v dt's, finding the summation here of all this is what we represent in calculus as integration, because we want to find the total displacement. So if we integrate both sides, if we do integration of ds equal to integration of v dt, what will we get? Therefore we get s, because when you integrate displacement, you get displacement. It will be the integration of v dt. So you can see it is exactly the reverse process. To get instantaneous velocity from displacement, we do differentiation, v equal to ds dt. To get displacement from velocity, naturally you will do the opposite thing. So instead of differentiation, you are going to do integration here. And integration of v dt over the time interval will give you displacement. Now you might be thinking, what is the time interval? That will be given to you. So normally you will see in the books they say over a certain time interval 0 to t, or you can write t1 to t2. So that will end up giving you the displacement. So remember this very important concept. And here again we are talking about instantaneous velocity, right? And the total displacement calculated from that. That is why we are using all this calculus stuff, ds dt and this integration of v dt. Don't get scared by this calculus terminology. I know initially it sounds confusing and scary, but it is just a transformation of the basic concepts that you have learned. We're just applying calculus here and we are getting these formulas. Clear? So let's understand how we can calculate displacement from instantaneous velocity using this example. So here we have been given that velocity of a moving body is given by v equal to 10t. We need to find the displacement from 0 to 4 seconds. So here you can see the velocity of the body is constantly changing, because as the time changes, it is 10 times t. Okay, so at time equal to 0, it is 10 times 0, 0. At time, let's say at 1 second, it becomes 10 meters per second. At 2 seconds, it becomes 20 meters per second. At 2.5, it will become 25 meters per second and so on. So clearly you can see velocity of the body is constantly changing. And this is the instantaneous velocity. This gives us the formula of the velocity at any time t. So how do we find the displacement from 0 to 4 seconds? So here once again we have to use that integration concept, because we have been given instantaneous velocity. And what was our formula? To find the displacement from instantaneous velocity, you need to integrate the velocity over the time interval. So we have to integrate v dt. Okay. And the time interval here has been given from 0 to 4 seconds. So put the limits from time 0 to 4 seconds. This is the integration, and that will give me the total displacement. That's it. So go ahead and substitute this 10t into the formula. So what will we get? From integration from 0 to 4 seconds, and this is 10t, the velocity is 10t dt. Now how do you do this integration? Whenever there is a constant, you bring it out. So this will be integration from 0 to 4 seconds, the 10 comes out, t dt. Now what is the integration formula in calculus? When we do integration, it is integration of x to the power n dx is going to be x to the power n plus 1 divided by n plus 1. This is the formula. Integration is the opposite of differentiation. There you had n minus 1, here there is n plus 1. Right? That was n times x to the power n minus 1. So here what is our power over here? You can see this is t. That means this is basically t to the power 1. So we just need to substitute n equal to 1 over here. So basically what happens? So this will give us 10 times, and integration of t dt will be t to the power 1 plus 1, t square divided by 2. So we are getting t square by 2, and the limits here are from 4 to 0. So the limits for this are from 4 to 0. So what does that mean? That I need to substitute 4 here and 0 and then subtract them, right? Because when you have limits, you basically subtract here. So it's going to be 10 times t square by 2. So with the value 4 here, so that's going to be 4 square by 2, and then you substitute minus 0 square by 2. Right? And so what do we end up getting? This will become 10, and this 4 square by 2 is basically 16 by 2, that's 8. 8 minus 0, and this is going to be 8 times 10, which is 80 meters. 80 meters is your answer. Again, this should have been given all in SI units, so it should be mentioned here, these are all in SI units. And your answer is going to be 80 meters for the displacement. So remember this important way of doing integration and finding the displacement. And also you guys should know that when you are doing this integration, when the limits are not given, it is called an indefinite integral. Then we put a constant over there, plus c. But when the limits are given, then this constant is not there. So that is why I did not add the constant here, because the limits were given to us from 0 to 4 seconds. If that was not given, then you need to add a plus constant, that is indefinite integral, and this was a definite integral. Because the limits were given to you, we substituted that, and there you can see we have got our answer. Now let's accelerate to acceleration. What is acceleration? The change in velocity divided by time, because it is defined as the rate of change of velocity. So the change in velocity by the change in time. We can also represent that in a formula like this. Acceleration A is delta V, that is the change in velocity, divided by the time interval delta t. And you've all seen this formula, right? Delta V, if you represent as final velocity minus initial velocity, so V minus U divided by t. So let's say the time is from 0 to t. But now, what if the acceleration is changing, right? What is the acceleration at a particular instant? Just like we had instantaneous velocity, how can we define instantaneous acceleration? Because once again, this will give me the average acceleration over a large time interval. So what this is really your average acceleration. Because acceleration need not be perfectly constant all the time. That will become a case of uniform acceleration. So how do I define that, or what is the formula going to be? So again, if we want to measure the instantaneous acceleration in a very, very, very small interval of time, what do we need to do? Again, we'll use calculus. We'll say in the limit delta t tending to 0, that means a very small time interval, my instantaneous acceleration, instantaneous. This is a very interesting word. Instantaneous. It has all the vowels, see? A, E, I, O, U, right? In fact, I think I just noticed that while writing. I hope I got my spelling right. It's a long word. So instantaneous acceleration is going to be, A will be, when the limit tends to 0, we denote it as dv by dt. This means very small time interval. So acceleration is dv by dt. This is the formula for instantaneous acceleration. And once again, you'll have that slope concept, right? So if you're having a velocity time graph, acceleration is dv by dt, so it is basically the slope of the velocity time graph. So remember these formulas. This is the formula for average acceleration, and instantaneous acceleration, you're doing a differentiation of the velocity with respect to time. Best way to understand formulas is with the help of an example. So let's take a look at this example here. We have been given displacement of a moving body s equal to 5t square plus 4t, and we need to find the instantaneous acceleration of this body. So how will you do it? Remember the instantaneous acceleration formula? Instantaneous acceleration A is dv by dt. We do a differentiation of the velocity. But what has been given here is displacement. We have been given s. No problem. We are going to first find velocity and then plug it in here. So we can start off with this relation. V equal to the instantaneous velocity V equal to ds by dt. So let's plug in this displacement over here. So we have ddt and the displacement is 5t square plus 4t. So go ahead and do a differentiation of that. So if you do ddt of 5t square, it's going to be 5 ddt of t square plus 4 times ddt of t. So what will you end up getting? ddt of t squared, like we saw, is 2 times t. You can use that n times x to the power n minus 1 formula. So this will give you 5 times 2t, and ddt of t is 1. You can easily remember that like this, right? dt and dt seems to be cancelling. So that's going to be plus 4. So I'm getting the 10t plus 4. In fact, we had seen this earlier when we had calculated the instantaneous velocity. Now we need to plug this in here. So what will we get? The instantaneous acceleration will be ddt, and we are basically plugging in the velocity in this formula. So our velocity is 10t plus 4, the instantaneous velocity. So do a differentiation here. What will you get again? 10 times ddt of t plus ddt of 4. 4 is a constant, so its differentiation will be 0. So therefore, finally we are getting ddt of t is 1. So 10 is the answer. Acceleration is 10. If units are not given, you can simply write 10 units. If these are given in seconds and all, you know, or SI units, you know it's going to be meters per second square. So here, in this case, the instantaneous acceleration value turned out to be constant. So it is actually a case of uniform acceleration, but it need not be. Maybe you could have got an expression like 10t or 5t or something like that. So this is what we have got here. So basically you can see, you can find acceleration as differentiation of the velocity. If displacement is given, it's like a double differentiation. So if you think about it, A is dv dt, and if we substitute v as ds dt, so this is like a double differentiation. So basically what you're doing, a ddt square of your displacement. So this is another way to look at acceleration, or you can start off with this and do the steps and get it. And remember here they just said instantaneous acceleration. They didn't ask you to find acceleration at a particular time. So when they give a question like this, you can leave it in terms of t. Suppose we got 10t over here, you leave it as that. Because they have not given you that I want to know the acceleration at this time, at 4 seconds, 5 seconds, nothing like that is given. So you can leave the expression in terms of t like that. We have seen how to calculate acceleration from velocity. But how do you calculate velocity from acceleration? So of course you can rearrange the simple formula and you will get velocity is acceleration multiplied by time. But the restriction here is that acceleration should be constant. So for uniform acceleration, this works great. You can get the velocity. But what if the acceleration is changing? Like in the case of instantaneous acceleration. So once again, we have to use the concept of calculus. Remember, how did we define instantaneous acceleration? Instantaneous acceleration is the differentiation of velocity. So dv dt. So to find acceleration from velocity, what were you doing? Differentiation with respect to time. So we were using differentiation. So I think you must have guessed that how do you calculate velocity from acceleration? You have to do the opposite of differentiation, which is basically integration. And that you can easily see from this equation, because if you rearrange it, so if you multiply take the time this way, so you get a dt equal to dv. Since I want to find velocity, I'll bring it on the left hand side. So I can say dv equal to a times dt. What does this mean? That if you multiply acceleration with a very, very small time interval, you will get the value of that small velocity. And to get the full velocity, you need to take a summation here, right? Summation in statistics we represent with sigma, but in calculus we write that big kind of S symbol for integration. So what you really need to do is, if you want to calculate velocity from acceleration, you need to integrate both sides. We can integrate both sides of the equation. So on integrating both sides, integral of dv will give you the velocity. That's our goal here. And this will be the integration of acceleration times dt. Again, remember, if the time interval is not given, then obviously it's an indefinite integral. You have to take plus a constant. But if the time interval is given, then you directly substitute the values here. So let's say you want to calculate the velocity for the time interval 0 to t. So your integration formula is going to look like this. So remember this important concept that to get instantaneous acceleration from instantaneous velocity, you do dv by dt. But if you want to get the velocity, the instantaneous velocity, then you have to do integration of the acceleration. So you have to do exactly the opposite, and to get velocity from acceleration, this time you need to do integration. So very, very important concepts. Please understand it and write it down. So let's see how we can calculate velocity from acceleration using this example. So what have we been given here? Acceleration of a moving body is given by a equal to 3t square. And we need to find the velocity at time 4 seconds if initially the body is at rest. So some condition has also been given to us. So once again, let's go ahead and apply our formulas of calculus and see what we can get here. So our goal is to find velocity from acceleration. The instantaneous acceleration is given to us a equal to 3t square. Acceleration is dv dt, but velocity is going to be the integration, the opposite, right? So if I want to calculate velocity, it is going to be the integration of the a dt, right? And if a time interval is not given, then it's an indefinite integral like this. So let's go ahead and substitute the acceleration expression here. It's going to be integration of 3t square dt. So what will that be, guys? You bring the 3 outside, it's a constant. Integration of t square dt. And once again, here use your maths formula that integration of x to the power n dx is going to be x to the power n plus 1 by n plus 1, and if it's indefinite, you will have a constant over there, plus c. So since no time interval is given, I'll have to take that constant plus c here. So what will be integration of t square? T cube by 3, right? So this is going to give me 3 times t cube by 3 plus a constant c. And this 3 and 3 will cancel here. So what are we left with? T cube plus c. So velocity is going to be equal to t cube plus c. This is my expression. And I need to find the velocity at t equal to 4 seconds. So if I simply substitute 4 over here, I'm still left with this plus c. This constant is irritating over here, right? I don't know its value. But we can find out its value because we have been given a condition that initially the body is at rest. Initially means time equal to 0. So for this special condition given to us, at time equal to 0, we know that velocity is 0. So see, using this, can you calculate the constant? Of course you can. So if you substitute it here, what will you get? Put v equal to 0, t equal to 0, so 0 cube plus c. So therefore you're getting your constant c is 0. So that's it. We know the constant is 0. So finally we can get velocity at 4 seconds. So at t equal to 4 seconds, v equals t cube, which means 4 cube, which means 64 again units, right? Or if it's in SI units, then it will be 64 meters per second. So here we are all assuming SI units here. So your final answer is going to be 64 meters per second, 4 cube. So see, just apply your integration, and again remember, if limits are not given, then you need to take a plus constant. If limits were given to you, then you'll have to just simply subtract. Suppose the limits were given, let's say 2 to 3. Then you just have to do 2 t cube from the value at 3 minus the t cube value at 2. So it will become 3 cube minus t cube. But here no limits were given, so we took a plus c and easily calculated our answer here. Here are the 3 famous equations of motion. And as we discussed, what is the restriction here? The acceleration A is constant. So these are all uniform acceleration where the acceleration is a constant value. Now you must have studied how to derive these equations of motion using algebraic methods and using graphical methods. But here we are going to do something very interesting. We are going to derive it using calculus. So we will start with those instantaneous velocities or instantaneous acceleration, all those concepts that we learned with all this differentiation, integration, and we are going to apply all those equations to derive these equations. Because remember, the equations that we have been looking at using calculus is for any general motion, right? The velocity does not have to be constant, the acceleration does not have to be constant, because it deals with instantaneous velocity, instantaneous acceleration. So those equations are valid in the general case. And let's see if we can apply that to get our special equations of motion where acceleration is constant. So we'll start with the derivation of the first equation of motion here. Let's look at the derivation of the first equation of motion, v equal to u plus at, this time using calculus technique. So we will start with the equation of acceleration. The calculus equation for instantaneous acceleration, we know a equals dv by dt. And the main trick about these derivations is knowing the starting step, where to start. After that you will see the flow is easy. So we know acceleration is dv dt. Now in this equation you can see the goal is to write velocity, the final velocity v is initial velocity u plus at, right? We want to derive this equation. So clearly we want to find v in terms of a. So what do? We'll rearrange this equation as we have done before, and so we'll write dv equal to a dt. And we know that if we integrate both sides, we should get the velocity. So I can apply integration on both sides, right? Now what will be the limits of integration here? In this equation, you know, we take the bodies going from a time interval 0 to t. So we can see that the integration for the time will be done in the limits 0 to t. And the velocity at time 0 we denote with u, that is the initial velocity. So here the limit will be u, and at time t we call it v. So you can see those are the limits for our velocity. So now go ahead and do the integration and see if you are able to get that equation. So when we do the integration on the left hand side, we have dv. So integration of dv is going to be v, and then you apply the limits here from u to v, initial to final velocity. What do we have on the right hand side? On the right hand side, we have integration a dt. But remember, in this, the acceleration is constant. That is the restriction of the equations of motion. It is a constant acceleration. The rate of change of velocity is constant. Velocity is not constant. The rate of change of velocity, which is the acceleration, is constant. Since it is a constant term, I can bring it outside, right, of the integration. So what will I get? A comes out, and we have an integration 0 to t of dt. So on the right hand side, we'll have basically integration of t will give you, integration of dt will give you t, and we apply the limits here from t to 0. And here you have v with the limits v to u. Now what is the meaning of this limits? Basically you set this variable equal to v and u and take the difference. So it is basically left hand side becomes v minus u. You substitute v and minus the lower limit, upper limit minus the lower limit. Same way over here, upper limit minus the lower limit, you substitute into t. So it's going to be a times t minus 0. Now go ahead and simplify this. This is very easy. V minus u equal to at. And if you rearrange it, what do you get? V equal to u plus at. And there you go. We have our first equation of motion, and yes, we have derived it using calculus. So we just applied simple integration here, starting with the formula of acceleration, or you can start off with dv equal to a dt, right? And there we have got our first equation of motion. Now let's take a look at the second equation of motion. Now let's look at the derivation of the second equation of motion, which is s equal to ut plus half at square. Remember, s is displacement, u is initial velocity, t is time, and a is acceleration. So we can see we are clearly interested here in displacement, there's velocity, time, acceleration. So let's start off with the velocity formula, v equal to ds dt. Since we want to calculate displacement, let's bring that on the left hand side. So we'll bring velocity and time on the other side, because you can see in the equation of motion, displacement is on the left hand side here. So I can write ds equal to v dt, right? ds equal to v dt. Now here we could do an integration, but you can see that the second equation of motion doesn't have v, the final velocity. It has u, the initial velocity. So this is where you can apply your first equation of motion, v equal to u plus at, and change this in terms of u and a. So what you're going to do is substitute v equal to u plus at from the first equation of motion. We are allowed to use the first equation because we have proved it. Okay. So we are getting ds equal to u plus at times dt. Now I want to find the displacement. That means we need to do an integration of this expression, because I've got ds, the small displacement, we need to add it up. So we will do an integration on both sides, and this will get me the displacement from 0 to s, and here the limits will be 0 to t. So once again, go and apply your calculus fundas and do this integration. So what will you get here? If you integrate ds on the left hand side, we'll get s with the limits s and 0. Okay, and what do we get on the right hand side when we are integrating this? So we will get, this expression is u plus at times dt. So when we are integrating it, we will get integration of from 0 to t of u dt plus integration of 0 to t of at times dt. You can break the plus down like this. So let's go ahead and do that integration. Here initial velocity is a constant number, so we will bring it out. So this becomes u integration from 0 to t of dt. Acceleration is constant in the equations of motion, so we can bring that out. Acceleration comes out here, integration from 0 to t of t dt. So what will you get over here? Integration of dt is t, and you have the limits t to 0. And here we have a integration of t dt is going to be t square divided by 2. So what we have over here? T square by 2, again the limits of t and 0. And on the left hand side, we have s with the limits s and 0. So go ahead and substitute the limits and you're done. So the left hand side basically becomes s minus 0, which is s, or you can write s minus 0 here. This becomes ut, t minus 0 is t, plus half a t squares. Since again it is from t to 0, so we'll put t square here, minus 0 will of course give you 0. So there you see we are getting s equal to ut plus half a t square. And we are done. We have derived the second equation of motion using our calculus method. Again, the main trick is to know how to start, and you go ahead and do the calculus method, you apply your integration, and you will easily get the derivation here. Now let's look at the derivation of the third equation of motion by calculus method. The third equation of motion is v square equal to u square plus 2as. We have acceleration a in here. So using calculus method, we can first start with the formula of acceleration. What is the formula of instantaneous acceleration? Instantaneous acceleration a is dv by dt. But if we just try to integrate this equation, there will be a problem because we don't want the time variable. There's t in here, but the third equation of motion does not have any time. So we have to do some magic and get rid of this time. And what we really need is a, v, they are fine, and we need displacement s. So what can we do here? Let's take a look. So what you can do, you can change this into, to get rid of time, you do dv by ds, and since we are dividing by ds, I'll again multiply by ds so that it cancels, and I'll shift the dt here. So write down, this is the magic step to get rid of the time variable. How do we get rid of the time? Because what is ds by dt? S is displacement. So ds by dt is rate of change of displacement. That means it is velocity. So this part, so this term here is simply velocity v. So what can we write this as? We can write acceleration a is dv by ds multiplied by the velocity v here. So see, time has been kicked out, time is not there. Now what do? Just cross multiply, bring the ds this side, and let's do some maths integration. So what will we get here? So we can do a ds equal to v dv. Okay. And now to get that equation, let's integrate on both sides. So when you integrate on both sides, so what will be the integration limits here? So let's say initially the displacement is 0 at the initial point, right? And the final displacement is s. And when I integrate velocity, the initial velocity we denote by u and final velocity by v. So these are my integration limits. Now go ahead and do the integration. For these equations of motion, you know the important thing that acceleration is constant. So since a is constant, we can bring it outside the integration. So what will this become? A and integration of simply ds. Here we have integration of v dv. So integration of v dv is going to be v square by 2 using that integration formula, and the limits will be from u to v. And when you do integration of this, what will you get? You will simply get s. So integral of ds will be s, and the limits will be from 0 to s. So now just plug in the limits, and what do we get? A times s minus 0 equals, we'll plug in these limits here, v square minus u square, or v square by 2 minus u square by 2. So you can have 2 in your LCM. Now just cross multiply and see what you get. So if you bring the 2 over here, we are going to get 2as on the left hand side, and right hand side will be v square minus u square. You can see we have got to the third equation of motion. Just rearrange it and you will get v square equal to u square plus 2as. There you go. We have derived the third equation of motion using calculus method. The main trick again is how to start. We started with the acceleration formula, and this was the magic trick you have learned. In fact, you can see there's a sort of a new formula you have here. A equals v dv by ds, or A equals dv by ds times v, and we use this to integrate and got our third equation of motion. So simple. Here's our formula summary that will help you revise what we have learned. So remember, we started with these three equations of motion, 1, 2 and 3, and you have done these before in class 9, right? V equal to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2as. These are the three famous equations of motion, but they have a condition. What is the condition? Even though they are accelerated motion, the acceleration should be constant. So here the acceleration in these equations of motion is constant. It is a fixed value. For example, 5 meter per second square, 10 meter per second square, whatever be the value, it is fixed. So it's accelerated motion where velocity is changing, but acceleration is fixed. Then you can use these equations. But if acceleration is changing, right, or we have this instantaneous velocity, instantaneous acceleration, then what do? Then please don't use these equations. You need to use these equations. These are the equations for this instantaneous velocity, instantaneous acceleration. So I'm going to write that word over here, instantaneous, so that you can instantly remember what to use. And what is the instantaneous formula? V equal to ds by dt. Remember, average velocity was delta v by delta t. So instantaneous velocity is ds by dt. Similarly, acceleration was delta v by delta t. Instantaneous acceleration is dv by dt. So what are we doing? We are doing a differentiation here with respect to time. We are using calculus. So you can get velocity from displacement by doing differentiation. How can we get the displacement from the velocity? How do we do that? You just do the reverse. You do integration. Reverse of differentiation is integration. So the formula is s equal to integration of v dt. It's easy to remember. Just take the dt this side and integrate. Same way, just like you can get acceleration from the velocity by doing differentiation, you can get velocity from acceleration by doing integration. Just the reverse. So I hope this formula summary will help you remember these important concepts, and do write down these formulas. The best way to remember formulas is to write them down, not just look at them. Okay, so go ahead and jot them down, and I'm sure you'll remember them. Now I have an interesting question for you. The question says, displacement of a moving body along the x-axis is given by x equal to 6t plus t cube. So the displacement is given in terms of time. You need to find the acceleration at time equal to 5 seconds. So go ahead and try this question and let me know your answers by putting it in the comments below. And I promise to reply to your answers. So go ahead, apply the concepts that you've learned and try out this question and let me know your answers by putting it in the comments below. Friends, I hope these kinematic equations of accelerated motion are crystal clear to you now. And remember, practice makes you perfect. So go ahead and apply these concepts and practice more questions on this topic. And if you like this video, hit the like button and share it out with your friends. And if you haven't subscribed to our YouTube channel, come on, hit that subscribe button and click on the notification bell so that you don't miss out on any of our videos. And do check out the full courses on our website and Android app. I'll put the links below. And the best part is you can try these courses out for free. We have courses on physics, chemistry, biology, maths, coding and artificial intelligence. So do check out these courses, because in these courses you're going to get live classes, interactive videos, quizzes, questions, mock tests and revision notes. So do check out our website manochaacademy.com. Links are given below, and share it out with your friends. and stay connected with us and just keep learning.